Good morning, good people. My name is Hendrik Makaneta, and as always, I'm going to teach you mathematics, grade 9. We have already indicated that if you have a question, please make use of the chat line to ask questions. Of course, you can also, at the end of the lesson, if not all your questions are answered, please feel free to send them through to me on my Twitter account at Hendrik Makane 3. Right, by the end of this lesson, we need to be able to solve geometric problems involving straight lines to find unknown angles. And of course, yesterday we spoke briefly about the angles on a straight line, which form 180 degrees. So I'm not going to waste a lot of time on the slides. 180 degrees, if you look at B1 plus B2 plus B3, they give you 180 degrees in that regard. And of course, we also looked at not only the 180 degrees, but also the vertically opposite angles. That is something that we looked at yesterday. And of course, we know that vertically opposite angles are equal. So this is what we know, that the vertically opposite angles have to be equal. And of course, we have looked at the 90 degrees there. We have looked at 90 degrees as well, where a line that is perpendicular to another line is demonstrated by AB as well as CD. Then you know that perpendicular lines always form 90 degrees. And this is something that we looked at thoroughly yesterday when we introduced this lesson on the geometry of straight lines. And of course, what is important is we have been able to solve some of the problems involving straight lines and vertically opposite angles. We looked at X in the first category there, where we were able to see that when you add X and 55, you must get 180. And of course, the value of X there was given as 125 degrees. And in the same note, the second one, the vertical opposite angles, someone asked, what if the vertical opposite angles are not equal? Well, it cannot happen. Vertically opposite angles are always equal. So I saw that question yesterday, although I answered it at the end of the lesson. Now, vertically opposite angles are always equal. That is one of the angles which you have learned about yesterday. And of course, we did a few problems which I'm not going to look at today, but rather I will be zooming directly into the different types of angles, looking at the transversal, the line that cuts two lines, at points of intersections. We have also spoken about this line. And perhaps today what we can thoroughly look at will be to define the different angles that are formed when a line cuts two lines at 2 points of intersection. And this line is called a transversal. That is the line that cuts two other lines at different points. Now, if you look at the first one here, we spoke also about the alternate angles. We did not do justice to this concept. So I would like to further define it, that the angles on different intersections, which are on different sides of the transversal, are called alternate angles. They point in opposite directions, as you can see. They form what we call a Z shape. So these are the two angles which are known as alternate angles. And remember, alternate angles are not always equal unless the lines are parallel. The two lines that are cut by a transversal, if those two lines are parallel, then alternate angles will be equal. But if the lines are not parallel, then the alternate angles will not be equal. And of course, coming back to the corresponding angles, we have seen that the corresponding angles in this case form an F shape. They too will not be equal if the two lines are not parallel. But if the two lines are parallel, then the corresponding angles have to definitely be equal. So that is what we mean when we say the two angles are corresponding angles. And of course, those are the two. Now, let's carry on. We have also looked at the interior angle. And we say that the core interior angles are also formed when the transversal cuts the two other sides. And these angles have to be inside of the diagram. In other words, they need to form a U shape, as you can see in the picture here. Once the transversal has cut the two lines, then these two angles that are within, that are found in between the lines, they are called the core interior because they are inside. Unlike the previous one, which was outside, these two are inside, therefore they are known as the core interior angles. Remember the keywords, corresponding angles, they are at the same position of each intersection. And of course, yesterday we had to look at a diagram where AB is parallel to CD. And of course, you can see that angles are formed when the transversal cuts the two parallel lines. There are about 8 angles which are formed. Angle 1, 2, 3, 4, 5, 6, 7, 8. Now, these 8 angles, there is a relationship between them. All 8 angles, you'll see that there's a relationship between these angles. And we need to define the relationship between these angles in a manner that will assist us to see the type of angles that are formed. If you can check there, we have got a wide range of angles that I've already spoken about this morning. I may have been fast, but if needs be, I will go back to each slide where we defined the angles. Let's start with the angles on a straight line. Is there anyone who can see the angles on a straight line? The two angles, just two. And I know that there's more than two, but only two. There are many. If you can check angle 1 as well as angle 4, those two angles are on a straight line. Those are angles on a straight line, the line being AB. What does this mean? This means that if you add angle 1 and angle 4, you will definitely get 180 degrees. So that is one aspect. And the two are not equal. Remember, 1 and 4 can be equal, but if you add them together, they will give you 180 degrees. Now let's look at the equal angles. I've already said to you this morning that vertically opposite angles are equal. What does that mean? This means that we have got several vertically opposite angles. Let's list them. Let us list only the vertically opposite angles. 1, you can see that angle 1 is vertically opposite to angle 3. So angle 1 and 3 are vertically opposite angles. Again, angle 2 and angle 4 are also vertically opposite angles, and they are equal. It doesn't end there. We also have another group or category of vertically opposite angles in the bottom line, CD, which is also cut by a transversal. If you look at angle 5 and angle 7, you will be able to see that that too means the two angles are vertically opposite angles. If you look at angle 6 and angle 8, those are also vertically opposite angles. So in other words, you've got about 4 pairs there. The first 2 pairs at the top there and the last 2. So those are vertical opposite angles, but at the same time, you also have the corresponding angles. If you look at angle 4 and angle 8, you know, they form what we call an F shape. And they too are equal. So they are called corresponding angles. 8 and 4 are corresponding angles. If you look at 1 and 5, those two are also corresponding angles. If you look at 2 and 6, they too are corresponding angles. And of course, 3 and 7, they are corresponding angles. So you also have corresponding angles, but at the same time, you also have co-interior angles. If you look at 3 and 8, they are inside. Those are co-interior angles, as can be reflected. But of course, you also have a wide range of other angles, like alternate angles. 3 and 5 are alternate angles. We've spoken now about the vertical opposite angles, which are 4 pairs there. We've spoken about the corresponding angles. There are 4 pairs, but there are 2 pairs of alternate angles. If you look at 3 and 5 in the diagram, 3 and 5, those are alternate angles. They form a Z shape. Z shape is formed, but equally 2 and 8 are also alternate angles. They too form the Z shape. We have spoken now about the vertically opposite angles, 1 and 3, 2 and 4, 5 and 7, 8 and 6. But at the same time, we're also looking at the next one there, which is corresponding angles. And of course, they too form a corresponding angle there. And of course, the next one, or the ones I spoke about, those that form 180 degrees. I've already spoken about those. And we said that they are co-interior angles 3 and 8, and then of course 2 and 5 form 180 degrees. The co-interior angles, they form 180 degrees because the line AB is parallel to CD. So just note, co-interior angles, just like angles on a straight line, they form 180 degrees. So the co-interior angles are not equal like the corresponding angles as well as the vertical opposite angles. Vertical opposite angles, they are equal. Alternate angles, equal. Corresponding angles, they are equal as well. But co-interior angles are supplementary, meaning that the sum of those angles is 180 degrees. And of course, that should be able to help you as we carry on. And of course, let me carry on with the lesson here. I wanted to carry on. We were still talking about the vertically opposite angles as well as alternate angles. Now, when you look at this activity here, You are requested to say whether the lines AB and CD are parallel in the following diagrams. Now, if you look at the first one there, 1A, you have a set of angles there, and those angles are alternate angles. The two angles are alternate angles. One is 95 degrees and the other is 85 degrees. So the key question here is, are the lines AB and CD parallel? That is the question. Are the two lines AB and CD parallel? So we're talking about these lines here, AB as well as CD. Are they parallel? Yes or no? The answer is no. The two lines are not parallel. Why do we say AB is not parallel to CD? And the answer is simple. The answer is the two alternate angles are not equal. So if you look at one of the alternate angles there, the value is 95 degrees, and the other one is 85 degrees. So therefore, the two angles are not equal, even though they are alternate angles, but they are not equal. So if they are not equal, this means that the two lines AB and CD are not parallel. If they were parallel lines, then those two angles were going to be equal. That is what we know about the character of alternate angles. Alternate angles are equal if and only if the two lines where they are found are parallel. Now let's go to B, 1B. In 1B, you can see we also have another set there of alternate angles. How do we know those two are alternate angles? I'm talking about 120 degrees and 120 degrees. How do we know that these two angles are alternate? Because they form a Z shape. You can see the shape that they form there is the Z shape. Now, in this case, we have to make a conclusion that AB will be parallel to CD. The reason being, they are alternate angles. And as you know, alternate angles are always equal. So alternate angles are equal. And of course, that means that the line AB is parallel to the line CD because those two alternate angles are equal. So in the first category, 1A, the two angles are not equal, but they are also alternate angles. Hence, AB is not parallel to CD. But in B, the two there are equal, therefore it means that the two lines are parallel. So AB is parallel to CD. That is one of the factors there. And of course, you can see that in the first solution, we have said correctly that AB is not parallel to CD because the alternate angles are not equal. And of course, in the second solution, B there, AB is parallel to CD because alternate angles are equal. And the next one, you can see we have the set of angles there. We have what is known as the corresponding angles, and the second one there, or D, is what is known as the core interior angles. Now, what did we say this morning about the corresponding angles? We said that if the corresponding angles are equal, then this means that your two lines will be parallel. So we have got corresponding angles here with 75 degrees, 75 degrees. So yes, even though our sketch is not drawn to scale, but it should be clear at this point that the line AB is parallel to the line CD. The line AB is parallel to the line CD. Reason being, the corresponding angles are equal. You have got 75 degrees and 75 degrees. Then we proceed to the next one, which is D. If you look at the point D there, you've got a set there of supplementary angles. How do you know they are supplementary? The sum of supplementary angles, the sum of the supplementary angles is 180 degrees. So if you look at those co-interior angles, they are also known as supplementary angles because their sum, if you add them together, they will give you 180 degrees. So 70 plus 110 gives you 180 degrees. And of course, this is how it goes in a star as the co-interior angles are concerned. Then we are proceeding to the next slide, and I hope that it makes sense. We have looked at the corresponding angles. They form an F shape, if you can see, F there. That's an F shape that is formed. But we also have the core interior angles, which are right inside the lines A, B, and DC. And of course, we also have another set. If you look at A, we are required to find the value of X. So for now, let's focus on A. 2A, calculate the unknown angles in each of the following, giving reasons for all your statements. Remember, in geometry, for every statement that you make, you need to give a reason. So what will be the value of X? In order to find the value of X, we need to look at the parallel lines that are there. We have EF that is parallel to CD. Of course, you can tell without doubt that the angle X and the angle 80 are corresponding angles. The key question now is, are the two equal or not equal? Is X equal to 80 degrees? Yes, X is equal to 80 degrees. Why? Because the two lines, EF and CD, are parallel. If the two lines were not parallel, then the two angles, corresponding angles, were also not going to be equal. Now that the two lines are parallel, then the two angles are also equal. And that is 2A. Now we can proceed now to 2B. In 2B, we also have parallel lines there. How do you know we have parallel lines? Because of the arrows that are found in each line there. So you can see you've got an arrow here in the line DE. You also have an arrow in the line, the second line there. And of course, the two lines are parallel, then they are cut by a transversal. And of course, they form what is known as alternate angles. So X and 35 degrees are alternate angles. So what does that mean? This means that The alternate angles in this case will be equal because the two lines are parallel. You've got the line DE there, which is parallel to the line FG. So the two lines there are parallel, and of course, this means that the alternate angles will also be equal. So at this point, we have now looked at the corresponding angles, X and 80. We have also looked at the alternate angles, X and 35, and we said that the two are equal. Now we need to follow through with the last one, which is C. And of course, you can see that we have got the line EF, which cuts the lines AB and CD at points G and H, respectively, where they form angles. Many angles are formed there. But we are particularly interested in the two angles, X and 40. And we want to calculate the value of X. Now, these two angles, X and 40, are known as co-interior angles, as we have said in the previous example. Those are co-interior angles. And we have said that co-interior angles, the sum of the co-interior angles must give us 180 degrees. That is what we have said. The co-interior angles, the sum of co-interior angles is 180 degrees. If and only if the two lines are parallel. Now, we are given that AB is parallel to CD, this information that is given to us. Therefore, we can conclude that X plus 40, the sum of X and 40 there must give us 180 degrees. Now, you have 40 already, and then you have X. The key question is, how much is the value of X if the other value is 40? So it means you have to subtract now 40 from 180 degrees, and you'll be left with 140. This means that the value of X will be 140 degrees, because if you add the two, 140 and 40, you get 180 degrees. And of course, these are the core interior angles, as we have already indicated. Now we can proceed. At this point, it is clear that we have looked at the different angles. We have looked at the core interior angles. We've looked at the corresponding angles. We've also looked at the alternate angles. But equally, we have discussed vertically opposite angles. So we have talked about 4 different angles which are formed when the transversal cuts the two lines together. And of course, we can proceed to the next category there. Say whether the lines AB and CD are parallel in the following diagram. So this is just to test you, but we have already done this. We've said that 1A, the two lines are not parallel because the angles are not equal. The alternate angles are not equal. And of course, the next one as well, the two lines are parallel because the angles are equal. So we've spoken about that. Now I have an example here. Excuse me. The example here, you need to now determine the value of X in this diagram. Now, In this diagram, you don't have any parallel lines. There are no parallel lines, but you do have lines that cut each other. For example, AD and BE, they cut each other at the point F. And whilst you are still there, a new line is drawn, FC, such that there are about 5 angles that are formed. Amongst them, you have X. Now, where there is X there, we need to find the value of X. Now, if you look at X, if you add X and 15, the sum of X and 15 there, that whole angle there, its value will be 140 degrees because those are vertically opposite angles. In other words, angle AFE is equal to angle BFD. Let me repeat. Angle AFE is equal to angle BFD. So AFE equal to angle BFD. Reason, those are vertically opposite angles. Now, the sum of X and 15, they will give you 140 degrees. So in other words, if you want to know what the value of X is, you need to subtract 15 degrees from 140. And of course, if you subtract 15 degrees from 140, you will be left with 125 degrees. So therefore, as you can see there, it means your angle X is going to be 125. But you will see that as we unpack it in the following slide, it will make a lot of sense. So just focus in the next slide. Just focus. We have said that the angle X, when you add it to 15 degrees, the sum of those two give you 140 degrees. And we have said the reason is vertically opposite angles are equal. And of course, you can transpose the 15 from the left-hand side to the right-hand side. And of course, 140 degrees minus 15 degrees. The answer that you get is 125 degrees. Now, we can also proceed and look at the next example here, where we must determine the value of X and Y in this diagram. Now, you can see that we have got parallel lines. GE is parallel to DF. Now, because of the parallel lines, we have got sets of angles there. Let me show you or inform you before we carry on to show you. There are two sets. One of the sets is corresponding angles which form an F shape. And those are 40 degrees and 3x plus 10. Those two angles there are corresponding angles and they must be equal. Why? Because GE is parallel to DE. Even though it may not be drawn to scale, but we are given that GE is parallel to DF. That is information. How do you know they are parallel? Because of the arrows there in each line. We've got 2 arrows here, 2 more arrows there. So this tells you that the 2 lines are parallel. Now, you also have another set of angles, which will be 4y and 3y plus 20. These two angles are known as alternate angles. And remember, alternate angles are also equal if and only if the two lines are parallel. In this case, DF is parallel to DE, and they form a Z shape, those two angles. So what you can do in order to find the value of X and Y, you can equate 3X plus 10 and equate that to 40, and thereafter you solve for X, and then you will get the X value. And secondly, you will equate 3y plus 20 to 4y, because these two angles are equal here. And once you have your equation, then you can solve now for y as demonstrated in the next slide. So as indicated, we have said that 3x plus 10 degrees is equal to 40 degrees. And of course, if you transpose 10 degrees from the right-hand side, from the left-hand side to the right-hand side, you will have now 40 minus 10, which gives you 30 degrees. So you will be left with 3x in the left-hand side and then 30 on the right-hand side. And of course, if you divide both sides by 3, whatever you do in the left-hand side must be done in the right-hand side. And of course, X will be 10 degrees. So as I said initially, you equate 3x plus 10 as well as 40 degrees. And those are corresponding angles because DF is parallel to GE. Secondly, you equate 3y plus 20, as I've said, with a 4y. And of course, you can solve for y there. If you want, you can transpose 3y from the left-hand side to the right-hand side, and you'll see that 4y minus 3y gives you y. Therefore, the value of y is 20 degrees. And remember, the reason why we have equated 3y plus 20 and 4y is because they are alternate angles. And as always, alternate angles are equal if and only if they are found on the set of two parallel lines. In this case, DF is parallel to GE, and that is why the two will be equal. The two angles are equal. I think that at this point, we've been able to demonstrate that when you are given such problems, you should be able to use or to make use of your knowledge of various angles, be it corresponding angles, alternate angles, co-interior angles, vertically opposite angles, or angles on a straight line. You can be able to use that knowledge to find any angle or any variable that is given at any time. Now, we have got one last example here. Given that A, B, C, D is a rhombus, determine the unknown values in the diagram. Now we are given this a value there. We are told that A, B, C, D is the rhombus. And there's something that you need to know about the rhombus. Something that you need to know about the rhombus is that the opposite sides are parallel and they're also equal. So the opposite side of a rhombus are equal and parallel. So this means that AB is parallel to DC, and that AD is also parallel to CD. And again, the opposite angles will be equal. In other words, if you take A, will be equal to C there. But of course, you can see that we have got an exterior angle there, which is formed by the extension of the line ED. That is an exterior angle there from the rhombus. If you take that angle together with angle A, you can see that they form what is known as the alternate angles. But before we go there, are there any other sets of alternate angles? Yes, there are. If you look at angle 25 degrees there, which is found on angle B, the small angle there, 25 degrees. That 25 degrees will be equal to Y, because they two form a Z shape. So meaning that Y and 25 degrees there at B, those are alternate angles. So you already have the value of Y, which is 25 degrees. And all that you need to do now is to solve for the other two angles. But if you look at Y and X, we will also come to that. It is always a good idea to fill in all the properties of a shape before starting to solve the problem. So ABCD is a rhombus. So we can fill in the following properties on the diagram that will help us. So let's look at the different properties that we are going to use. Of course, if you look at the first one there, we say that Y is equal to 25 degrees. I've said that already. Why? Because the alternate angles are equal. We are given that AB is parallel to CD. So that is one of the properties of a rhombus. It consists of alternate angles, especially because of those diagonals that are there. So Y and 25 are alternate angles, and alternate angles are equal. Why? Because AB is parallel to DC. They are not only parallel, but they are also equal. And again, if you look at AOB, one of the properties of a rhombus, diagonals form 90 degrees where they meet. The diagonals of a rhombus form 90. So AOB, you can see that angle AOB is 90 degrees because the diagonals of a rhombus, where they intersect, they form 90 degrees. So now you have got 90 degrees here, which is formed as a result of the diagonals of a rhombus, but equally, you have got 25 degrees there. So you can use the sum of the angles of a triangle AOB. If you add X, 25, and 90, you should be able to get 180 degrees. And of course, if you add 25 and 90, you get 115. That's what you get. This means that if you subtract 115 from 180, you will get 65 degrees. So your value of AX there will be 65 degrees, as you can see in this particular activity. And of course, the last one will be to find the value of Z. So to find Z, in order to find Z, again, we are talking now about the alternate angles. Remember that we have now found 25 degrees as the value of Y. But of course, if you add them together, you can see that if you were to add 2z plus 10 plus 25, which is the value of y, plus another 25, you get 180 degrees. Those are angles on a straight line. So the angle that is here, angle ADB, will also be at 25 degrees because the line AB is equal to the line AD. Remember, this is a rhombus. All four sides are equal. Then you can be able to solve for Z. And of course, if you add them together, Z will give you 60 degrees. So for your homework, I think that let's determine the sizes of the following angles and give reasons. Let me give you this homework. There's a diagram in our midst. I want you to proceed to solve different values of angles there. We've got angle A1, A2, B1, B2, C1, D1. Those are the angles that I want you to solve. And of course, you can use all the knowledge that we have gathered today in as far as the parallel lines are concerned. You can see we have the line FB, which is parallel to the line ED. You also have the triangle ABD there, where A is 90 degrees. And of course, for more information, you can visit some of our sites. I invite you to the next lesson where we will finalize the geometry of straight lines before the end of this week, I think tomorrow. And of course, if you have more information, please reach me on 082-623-2148. You can also reach us on the Twitter account at Africa Team Geeks, also Facebook account Africa Team Geeks. And of course, this lesson was brought to you in partnership with the Sasol Foundation, in partnership with the STEM champions from our lockdown digital school. Please feel free to also reach out to the website of the DBE. Until we meet again tomorrow, thank you very much indeed.